Well, to touch the perfection, Toyota is looking into ways to increase the competitiveness of EVs planned for this decade, like accelerating the adoption of performance-boosting technologies for EVs in the works, such as electric drive systems, electronics that convert power from the grid to energy stored in batteries, and more integrated heating, cooling systems, and whatnot. Well, if there is more to the story, the CEO has something else to say, which will shock the EV market. Join us here at Tech Addicts to find out what all the buzz is about, and let's begin. To close the price and performance gap with market leaders Tesla and BYD, Toyota Motor Corporation is set to explain revisions to its electric vehicle strategy to major suppliers early next year, according to two individuals familiar with the matter. The key suppliers will be informed of the revisions to the EV plan through early 2026, and the world's largest Japanese manufacturer will announce those changes publicly. Accelerating the adoption of performance-boosting technologies for planned EVs, including electric drive systems, including motors, electronics that convert power from the grid to energy stored in batteries, and more integrated heating and cooling systems is one way Toyota is looking to improve the competitiveness of EVs planned for this decade, according to those sources. One of the persons stated that among the adjustments could be postponements of some of the EV development programs initially scheduled for the 3-year time frame. The people also said that the alterations would be made to the successors to the bZ4X and the Lexus RX, Toyota's first two mass-market EVs, to bring them closer to competing with Tesla Inc. in both price and performance. At the first worldwide supplier convention since the pandemic, Toyota will hold a massive supplier meeting in February. In a statement, Toyota said it is constantly having conversations and collaborating with important suppliers and partners on a wide range of themes to reach carbon neutrality. However, the company claimed it could provide no further information about its EV development plans. According to analysts, Tesla, owned by billionaire Elon Musk, made almost 8 times the profit per vehicle as Toyota in the third quarter, partly due to its ability to simplify EV production and lower cost. Reuters reported in October that Toyota was reconsidering its $30 billion, 3-stage strategy for developing and delivering EVs, first revealed late last year. While an internal group led by ex-Chief Competitive Officer Shigeki Terashi investigates ways to boost cost, performance, and technology in the burgeoning EV market, the company has temporarily halted development on some battery-powered car concepts it unveiled last year. Toyota has tasked the working group with developing a strategy to better its electric vehicle efforts, which includes looking into a possible successor to its new EV platform, e-TNGA. Toyota still thinks gasoline-electric hybrids, a market pioneered with the Prius, will be essential to the shift to carbon-neutral transport. Therefore, the redesign is happening even while the company maintains that stance. Green investors and environmental groups have pressured Toyota to speed up its EV transition since industry-wide EV sales have surpassed the company's earlier projections. Most major manufacturers predict EVs will account for most vehicle sales by 2030. e-TNGA. As part of its EV goal, Toyota has been releasing models like the bZ4X, the first in a line of battery EVs dubbed the Beyond Zero series. According to rumors circulating throughout Toyota's supply chain, the planned second phase will roll out sometime in the next few years, when Toyota will have multiple vehicles ready to roll out based on the e-TNGA platform. Alterations to this stage will most likely be communicated to vendors in the first few months of next year. People familiar with Terashi's teamwork have indicated that they are currently debating whether or not to abandon the 3-year-old e-TNGA design, which was developed by altering a gasoline automobile platform in favor of a dedicated EV platform. Toyota engineers now see that factory floor innovation is key to Tesla's strength. Still, e-TNGA was designed so EVs could be made on Toyota assembly lines alongside gasoline cars and hybrids, and thus it compromises the automaker's capacity to provide such breakthroughs. Furthermore, sources have stated that Toyota based e-TNGA's development on the expectation that it would need to sell roughly 3.5 million EVs yearly, or about 1/3 of its global sales, by 2030, despite the industry prognosis predicting a quicker rate of growth. Regarding reviving its electric vehicle division, Toyota has been working with two suppliers, Denso and Aisin. Aisin and Denso have been working on a new thermal management system. The company is considering that if it can speed up the industry's adoption of that technology and potentially Aisin's more advanced electric powertrain or e-axle. Toyota's considering using Denso's newly developed silicon carbide-based inverter in select large luxury EVs because of its positive effects on charging times and production costs. This will be a game changer for Toyota. The product, the launch of which is anticipated for the year 2027, will feature an astonishingly space-saving design as seen in the following image. In comparison to the e-axle of the first generation, the objective of the development process for the third generation e-axle is to cut the size in half. The goal of downsizing has been aggressively pursued and significant progress has been made. When asked for a remark, Denso and Aisin both remained silent. Some have taken Terashi's return to the spotlight and overseeing Toyota's EV strategy assessment as a hint that the car maker is getting ready to pivot to EVs after neglecting the technology. When asked for a remark, Terashi, age 67, did not provide one. Terashi has been one of Toyota's leading vehicle strategists for the past 42 years and an outspoken supporter of hydrogen and other zero-emissions transportation. He worked on the group that paved the road for Toyota to partner with BYD, the largest EV manufacturer in the world, based in China. An outcome of this collaboration is the BZ3, a Toyota-branded electric automobile sold exclusively in China and powered by batteries made by BYD. Also, the company is striving for advancement in the increasingly competitive market for electric vehicles. Toyota, the world's largest automaker, announced that it would invest an additional $2.5 billion in a U.S. factory, producing batteries for hybrid and battery electric vehicles. The $3.8 billion plant producing Toyota batteries in North Carolina is expected to open in 2025. The Senior Vice President of Unit Manufacturing and Engineering for Toyota Motor North America, Norm Bafuno, called the news another big milestone for the company. Toyota has noted an increasing demand for battery electric vehicles, prompting the company to announce plans to invest up to $5.6 billion in battery manufacture, including an increase in investment in the United States. The company plans to increase combined battery production capacity by as much as 40 gigawatt hours in the United States and Japan. Toyota is well known for its diesel and gasoline automobiles and its hybrids and hydrogen fuel cells. Also, it's trying to make headway in the battery electric industry, where companies like Tesla and Volkswagen are vying for customers. There have been some difficulties along the way. More than 2,000 of Toyota's BZ4X all-electric SUVs were recalled in June 2022 due to potential safety issues. While the company has stated that it plans to invest billions in electric vehicle battery production, it also emphasized on Wednesday that it will continue to make every effort flexibly to meet the needs of customers in all countries and regions by offering multiple powertrains and providing as many options as possible. The internal combustion engine is still the most prevalent method of powering vehicles, and will continue to play a role for the next 20 to 30 years, according to Toyota Europe's website. This is happening at the same time that many developed nations are formulating strategies to lessen the negative effects of automobile travel on the environment. Just this month, the California Air Resources Board adopted a law that will mandate all new automobile sales in the state be zero-emission vehicles by the year 2035. The United Kingdom plans to end producing and selling new diesel and gasoline vehicles by 2030. By 2035, all newly manufactured automobiles and vans must be emission-free. Well, as we all know, these last several months have seen a shift in the battery industry toward solid-state batteries. The world's biggest original equipment manufacturers, or OEMs, and even Bill Gates are putting billions into this field. And several new entrants, all with deep pockets, are claiming to offer the next step change in battery performance necessary for an all-electric future. So what are these batteries exactly all about? Faster charging, higher range, and longer battery life are all possible because of the solid electrolytes used in solid-state batteries, which are safer, non-flammable, and more energy-dense. In addition to functioning at extremely low temperatures, they are better equipped to endure the heat. Solid-state technology is expected to cost between $400 per kilowatt-hour and $800 per kilowatt-hour by 2026, although it's highly expensive to produce. In light of this, the auto sector will have a harder time getting to $50 per kilowatt-hour in the coming years. Some solid-state batteries' mechanical and thermal durability degrades with increasing cathode thickness. There's a lower upper bound on the amount of energy that can be stored in the cathodes per unit volume. This can hasten the breakdown of energy components and lead to to an early failure. Since the power output of a battery is inversely proportional to its energy density, optimizing this ratio has been a driving force in battery research and development. Thicker cathodes reduce power output by restricting diffusion. Hence, solid-state batteries have not yet achieved this aim. Well, all we have to say is, it's worth the drive. That's all now for today's video. If you want to see more amazing content, then don't forget to join us at Tech Addicts. What are you waiting for? Hit that bell icon now.